Okay, so now I'm in the Analyze Optimal LDA model file, and I have cleared the environment. I will now load the optimal LDA model that has been saved from the execution of previous data file. So I got my articles, and then I get this doc topic distribution. And here on lines 31 to 41, I create some important variables that makes the further analysis a bit easier with descriptive variable names. And now I can list the top 10 terms for all topics. Okay, so I just found a bug in line 32, which says terms LDA winner 50, and obviously this does nothing, as LDA winner is not defined. I'm not sure how the bug got there, but it should be simply terms and 50 like this. And now executing lines 35 to 41 makes more sense, and we can get the top 10 terms for all topics by executing line 45. Or we could if it wouldn't be omitted over here. Well, we can study any single topic by having the terms 1 to 10 and simply selecting the topic number. So for 1, we get topic which is related to failure equations. And if we take topic 2, we can see it's about level, context experts, and so on. And topic 3 would be about safety analysis, and so on. Okay, so lines 50 through 51 list simply all the papers that are part of topic 1. And we can also get the abstract by executing line, so on. Now, if we start to look for the hot and cold topics, we can take the median number of when the papers of the topics have been published. So this is one approach for searching for the hottest topic. We can see that topic with work account repair Android apps appears to be one of the most hottest topics. And these are the papers in this topic. And now if we look into the coldest topic, we can see that it's about structs or hierarchical nodes and so on. And we get paper titles also for that topic. We can also do density plots here in 65. We could. Okay, so it seems that the line 65 didn't work. I think I have too many topics, but line 67 executes. And here we compare the hot and the cold topic. So we can see that the cold topic, which was about hierarchical structure nodes, has been most popular in 1980s and has disappeared in 1995. And then this other topic, which was improving what is this? Interaction efficiency, and they have mostly started to appear. Well, they are all very recent. Basically, they have appeared in the last 2 years, as it seems. Okay, I just realized that my topic modeling, although I have performed a search to find for the most optimal topics, I realized that this does not make very much sense, because as we can remember from the previous file, you can find the location, we split this to 298 topics. And the thing is that we only have 3,500 papers. So this means that roughly only 10 papers or let's say 12 papers per topic on average would appear. And the trend analysis does not make very much sense in that case, because the trend analysis requires that we could see how the trend is developing. And we can also see it in these topics that are not very easy to interpret by a human. So interaction number, respect, improving, and so on. So I realized that despite of this mathematically optimal model, this model is not very good for the analysis I want to do. So I need to redo this analysis of building the model. I realized that this, the results will not be very good for the hot and cold topic analysis. Okay, so I have recreated the model in line 97. I set the number of topics to 50. This would mean that each topic would have roughly, let's see, it would have roughly 70 papers, which is enough for the trend analysis. I mean, we can get yearly trends, and then I have set the topic prior to 0.1 and the topic word prior to 0.01, which are the recommended defaults. But of course, I mean, you should optimize these, but not right now. Okay, now with our new model, we can look at what are the hot and what are the cold topics by using the median approach that previously failed. So we take the hottest topic, and it appears to be source code changes. And we can see that it has 84 papers. So now this starts to make sense. And now if we look at the coldest topic, we can see that it's about program control graphs. And it has about 77 topics. Okay, and now as we have a smaller number of topics, also the Q-plot in line 65 works. And we can see the density plots on how the popularity of different topics goes over time. And then we can look into hot versus cold, and we can see that the distribution is quite different for the hot and for the cold, which we identified in the lines 57 and 60. Okay, and through the execution of lines 70 and 76, we do some mathematical setup, and now we can see which topics are the most cited when it's normalized for time. And it appears that the research on empirical studies is the most cited. If we look at the most cited in total, here we ignore the paper count, and we can see that it's metrics on object-oriented design. There are some very highly cited papers. We can also look at the topic age, and we can find that the oldest topic is about distributed communication protocols. And finally, on line 81, we can find which is the most popular topic in terms of paper counts, and it appears to be distributed communication protocols. And then lines 88 and 92 simply give the same as above, but they give the top 5 for each of the previously mentioned categories. Okay, now we move into the trend analysis. There is a value here on line 108 that you might want to edit, where you can basically say which years are taken into consideration when doing the analysis. I will simply edit out the line 108 now, but this can be useful if you want to exclude some years and decide the timeline you want to do the editing on. Okay. And now we execute the significance analysis, and we can see that there is 13 topics with significant positive trend and 10 topics with significant negative trend. And now we list these topics, or actually we plot them. Okay, as you can see, my attempt to plot ended in a failure. So I have duplicate labels. Took me about 30 minutes to figure out why this is. It appears, if I look at the coldest topics I have 5 cold topics. So first is parallel memory, then it's specification formal, specification language, distributed communication, and model Petri. And we can see that specification is top word on 2 of the 5 cold ones. And the plotting does not really like that. And in fact, neither do we, as we would have 2 specification and then we would not know which is correct. So actually, a good fix to this is to go back top here already where we did some fixes, where we selected top 50 words. And now we also want to set in the lambda value so that we get more meaningful words on the top, not just words that happen to be very common, like the specification, for example. So we set this fixed line here in line 33, we set it to 0.3. And now we simply re-execute and hope that we can successfully plot this. Okay, perfect. Now this seems to fix my problem. And we can see that it now plots. Now if we execute here, we can see that we get visual graphs. But as you notice that the graphs, they do not look very nice. I mean, the trend lines are mostly outside of the scope that we try to plot. And now how can we get around this? Is that we take the source code file, tsysr, and we open up this file, C16 trends fig 5 hot and cold adjusted. And okay, so we open up this file, and in ylim we can see values 0.005 and 0.025 that set the scale where this plotting is about to happen. So here on line 16 we make some edits. We can see that it actually comes from lower than 0.005, so let's put in 0.002, and then we need to also adjust this value. I will simply set in 0.04. And now I try to replot, and I hope that I get a plot that makes sense. Not yet, have to continue iterating. Let's go to 0.8 and hope that we get a better figure. Back to the analysis, optimal model file, and execute line 147. And now, not quite yet, but almost there. .05 is probably enough. Right, now it plots actually quite nicely. So the hot topics are here on the right. We have code, test, developers, visual, and research that are going upwards. We can see upward trends. And then things that are going down are parallel, formal, notation, distributed, and Petri. And finally, to figure out what are the other words behind those hot and cold topics, we can look into execute line 149 to get the hot topics. So we have source code and bugs, testing and fault, developers refactoring, visual automated tools. And for the cold topics, we have parallel multiprocessors, formal specification, notation transformations, distributed protocols, and Petri nets. And as you can see, my specification problem has disappeared. So the specification was here on topic 2, and also on topic 3. But now, due to the lambda adjustment, we get more descriptive most probable words.